Graphing. It's like solving the elimination or substitution method with a picture instead of using algebra. So the first important thing is knowing how to graph. So if you said y equals 2x minus 5, right? The 2x is the 2 is the slope, which means it rises 2 and goes over 1 and repeats that for the slope. The minus 5 is the intercept, which is the point we put on the y-axis. It's to intercept means to cross, so it's where it crosses the y-axis. And let's say we have another one. Just make up an equation. So the solution would be where these two graphs meet. So again, if you look at minus 2, that's where the intercept is. And negative 3/4 means you went down 3 over 4. So then, the solution of these two is where the two have something in common, where both of them have an input and output, or an xy that is shared, which is right here. And it might be a decimal since I made up this equation. So then you get to sometimes having greater than or less than. So let's make the first one greater than and the second one less than or equal to. So the first thing is to look at greater than. Greater than has no equal sign, so it's going to be a dotted line. And that was the green line, so I'll just take the green line and dot it. And then greater than. Think of gravity and a ball. Where would the ball fall off of the mountain? So if you're going up the mountain, you're going to go up or down it here. But if you put the ball on the bottom here, right, gravity wouldn't let that happen. The ball would fall down. It would fall off of the track if you think of that as a track. So greater than is the top one, and less than is where the ball would fall off. So that would be less than. So we have greater than. I guess it's not easy to erase. We have greater than for the first equation. I made it blue here, the dotted line. So I will highlight or shade in everything. Again, greater than, where the ball can stay on the track and go up or down. Greater than. Generally, greater than is up, less than is down. But that doesn't always work. So I like to think of that little ball trying to stay on a track. Let's take the second equation. It's less than and equal to. So the second equation has an equal to sign. That equal to means it's a solid line. So this line, when we graph it, would be solid. And greater than would be up and less than would be down. But to be sure up is up and down is down, think of those two wheels on a track. The top one would stay on track and go up and down. The bottom one would fall off. You can't, with gravity in the real world, you can't do that. So that downward would be less than. The solution, when you have a less than and greater than, is where the two colors have something in common, right? So here the dotted line, here the solid line, have the shading in common, and that would be our answer. All of these values for x would work because they're going to be inputs and outputs in common for the blue and the red line. So that's how we shade. It's a little bit different way of explaining it. Some will understand it one way, it'll stick, another it'll stick a different way.